Hey everybody, this is Alex Merced from alexmerced.com, and this is the first in a series on using data libraries in Python. Now, I'm not a data scientist. I'm new to the data space, but I'm now working in the data space. I'm traditionally more of a web development guy. But I figured since I'm going to be learning more about this, you guys can learn with me. So if you're someone who's interested in data and learning how to use Python with data, we can explore this topic together through this video series. So this first video series is going to be more like introductory, like how to get your setup going and what the different pieces are and why do you use the different pieces. Okay, so we're going to set up our Python data sort of canvas or place where we workspace. So what I've done is I've opened a new folder here in Visual Studio Code. So if you don't have Visual Studio Code, go download Visual Studio Code, just Google it. And I created a folder called Python data, and that's the folder that I have opened inside Visual Studio Code. I am working from a Linux machine, but generally everything that I'm going to do should apply to any operating system. The only difference is that some of the commands may be different if you're on Windows, since Windows by default doesn't use a bash shell, although you can then mirror that by downloading a piece of software called git bash. Okay, but now first let's just kind of talk about like why Python for data. So there are several languages that are used for doing data work. Technically, you could use any programming language for data work. There are languages that are literally mainly really targeted towards doing data work, such as R and Julia, okay, which are great languages to learn. Doesn't hurt to learn those if you're in the data space. And that's more on the data science, data, and the analytics side, okay, analyzing data. Then there's languages that are used more on the data engineering side. So not necessarily to analyze the data sometimes, but more so to transform the data and to prepare the data from getting it from its source. So you would export the data from wherever it came from, so some database somewhere, some log documents, streaming data from like an Apache Kafka server. You would export that, transform it, okay, using tools like Spark, Dremio, etc., to make it available for consumption, to load it at its target destination. This is also known as ETL, okay, export, transform, load. The idea being, so that's what the data engineer does. They're thinking about that pipeline of where the data came from to where the data, how the data needs to look like, where it needs to be, so that way the data analysts and the data scientists can use it. Okay, and generally there you're going to see like Java, Scala, a lot of Scala, basically languages there, just because a lot of the tools there are very much based in sort of the Java ecosystem. Cool. So where does Python fit into all of this? Well, Python kind of fits into both worlds. Okay, so if you are a data scientist or data analyst, which is going to be more sort of the focus of this video series, you might be using libraries like, well, you'll definitely be using what's called a notebook. And you'll see what a notebook is. It's kind of like a way of kind of creating a document that evaluates code on the fly and creates like sort of visual output. You can use this to then like load different libraries you want to work with, load data you want to work with, do all your analytics. You can actually create visuals right there in the notebook. Or what you can do is just prepare the data, have a visual way to make sure that the data is prepared the way you want, and then export it to other tools like Tableau or Power BI from Microsoft to create that dashboards or you know, and so forth. So we'll talk about all these sort of different ways you can use it, but that's essentially like it's going to center around a lot of using notebooks, okay, particularly what's called a Jupyter notebook. And then you'll use libraries like Numpy, which the reason we would use Numpy is because what it does, it creates a faster version of an array. And when we're working with large data sets, speed really matters. So here, like data structures, how we structure our data is going to be really important because it's going to affect the speed at which we can evaluate it. So instead of just using standard Python lists, which are much slower in the way they're sort of created because they're supposed to be much more flexible, Numpy gives you typed arrays, which allow you to basically the way it just allocates things in memory is going to be a lot more efficient, a lot more faster. And then that Numpy library gets used in libraries like Pandas. And what Pandas does, it allows you to take a look at data through a structure called a data frame. So while we'll typically, when we think about like a table, like a collection of data, we think about rows. So there's like the first row of data, the second row of data, third row of data. Looking at data structuring data as rows actually makes it kind of slower to search and look through it from a computer's perspective. Okay, because if you're looking for everything that has this one thing true, then it has to go through each data piece in each row to kind of find whether that thing is true. So what a data frame does is that it's going to structure it into columns. So it's going to be more of a columnar setup where each column is an array, because then you can isolate columns and say, hey, just find me the one whose age is this. So then it only has to look through that age array of her age column. So that's going to be a much more faster structure. So pandas is going to allow us, and then basically those arrays of columns are really Numpy arrays. So again, there's where Numpy comes into play. So pandas is going to be really sort of your main sort of tool for analyzing, in a sense. So basically you'll grab data from different places, load it into a pandas data frame, and then do what you need to do with it. There's other tools like PyArrow. PyArrow is part of the open source Arrow project, which is kind of really sort of optimizing the ability to represent data in a columnar format, especially in memory. So pandas kind of already uses PyArrow quite deep now, I think more deeply under the hood. So a lot of so kind of like NumPy, PyArrow, or the Arrow format in general are things that you're just going to vicariously be using when you're using pandas. So yeah, and then there's a bunch of other libraries like scikit and whatnot for like different applications, depending on what you're trying to do. But just that way you get to. But again, you can also use Python in doing engineering work with tools like PySpark and other things. Cool. So now that you kind of got the lay of the land of what's going on here. So again, there's basically three sort of main roles. There's the data engineer, who basically is focusing from moving data from point A to point C. And then once the data is at point C, basically your data scientist will take that data and create machine learning algorithms. And then your data analyst will break down the data, pull it in to create business insight dashboards. So that's sort of the big picture. There's definitely a lot more sort of granularity and complexities and all of that, but that should kind of ground you on sort of the why and the what, versus being like a web developer where you're creating the application that users use that generates all this data. Okay, so basically we're analyzing that data that user interactions have generated, user submissions have generated, and so forth. Coffee. Okay, so let's set up our environment. Now, what we want to do is we want to create a Python environment to install all the libraries we're going to be working with. Some people will install something called Anaconda. Anaconda is one way of sort of managing your Python dependencies that's really geared towards data science. So instead of like, what it does, it has pretty much a lot of the standard stuff kind of downloaded and installed right off the bat. And the different repository where it can have different versions and of things. So like I know like there are certain newer versions of certain libraries like scikit that you find the newer version of Anaconda, but not necessarily on Pypal, which is the default repository for Python, the default place where it's pulling these libraries from. Although generally not a big deal. We're just going to be working with a standard Python environment. So if you have Python 3 installed, I have Python -- version 3.10 installed. Okay, and I do have a piece of software called PyEnv. And what PyEnv does, it allows me to switch between different versions of Python. So if you wanted to use different versions of Python, I would recommend installing PyEnv and using that as your way of managing which version of Python you're using at any given time. So I can go back and forth, because every once in a while you run into someone's project who needs an older version and you gotta downgrade. So, but I'm not going to get into installing Python and PyEnv, but those things you should have installed. Just Google how to install them for your operating system. But once you have that installed, we want to create what's called a virtual environment, which is just essentially a isolated collection of dependencies, in a sense. That we can flip the switch on and say, hey, we're working with this group of dependencies right now versus that group, when we're working on these things. So that way I don't have to mix all my dependencies that I use for when I'm doing web development with ones when I'm doing like data work. So we'll say Python -m-venv, which means I want to use the virtual environment module that's built into Python to create a new virtual environment, and we'll just call that environment we'll call it DataPy. Okay, and what that's going to do is going to create this new folder called DataPy. In there, okay, there's a script. So we opened up this folder. See, this is a folder called bin. Bin always stands for binaries, so there's a binary script in there. That's this script right here, activate. Okay, and if you look at it, it's just a bash script. Okay, and all this bash script is doing is just that it's changing when you run the Python command, where it's looking for dependencies. Okay, and then you can change it back whenever you want to the default. Okay, so if I do this, so to run that script, what you want to do is you type in source ./datapy, because that's the folder, /bin, that's the binary folder, and inside the binary folder there's the activate script. So I'm going to play that and see now what it does, just to make sure that you activated it. It puts this right here, so you know you've activated that virtual environment. And to turn it off, all you have to do is do deactivate, and then that'll put you back into your global Python environment. But if you install things not in the virtual environment, they're going to always be installed. They're installed globally. You generally do want virtual environments so you can isolate your dependencies. But I'm going to turn that back on. Okay, and the main dependency I'm going to want to install right now is going to be all the notebook stuff. Okay, there's 3 libraries we want to install. Okay, we're going to want to install Jupyter Lab. That's going to be sort of like the fanciest of the notebook tools. Okay, so we're going to do pip install Jupyter Lab. We also are going to want to install Notebook. That installs the OG or original Python Notebook library for whenever you might need that. And then voila, voila is going to allow you to take, oopsies. Okay, voila is going to allow you to take like a notebook and turn it into a standalone web application, or like nest it and do some fancy things. So we're going to have that installed so that way we can work with that, because that's mainly what we're going to be working with. So that'll take a second to install all of that. So it uses Tornado. Tornado is actually a web framework, so I'm assuming that when it's serving you the Jupyter Notebook, it's actually using Tornado as the web server to do that. So that's good to know. Or maybe that's for voila. Again, I'm just looking at these lists of dependencies, seeing if anything I recognize. Matplotlib, that's going to be a library that you can use for like doing a lot of different like visualizations and graphs and stuff. Anything else I recognize? No. But nothing. All things we can easily like look up. WebSocket's probably for doing WebSockets. Okay. Which is kind of like an open connection between 2 spots. So instead of like a normal HTTP connection where you send data, data connection closes, server then sends a response, it would be this open connection. That's usually how you like handle chat. Okay, so what I want to do is I'm going to make a folder. So I'm going to do make dir, mkdir, to make a directory. I'm going to make a directory called notebooks. So this is where we'll have our notebooks. So I'll cd into that notebooks folder. And then I'm pretty sure the command should be Jupyter Lab. Let me just confirm that. Yep, we just type in Jupyter Lab with a dash. So basically when we installed it, it was without the dash, with the dash when you use it. That's one thing I always notice in the Python world, where like a lot of times like you install the library under one name, but then the command line commands are under a different name. Well, like again, I've spent a lot of time in JavaScript, especially if you've been watching my channel for a while, you know I've spent a lot of time in JavaScript. There, like everything's kind of generally matches the name of what you just installed. Okay, Jupyter Lab. Okay, so what that does, it's going to run a server from this folder. So this folder now, I can generate notebooks in it, and it opens up this program here. So this Jupyter Notebook program, and this is working out of that folder. So if there was any notebooks already in there, they would show up over here, and then I can build different types of notebooks over here. So I can choose kind of like what I'm trying to do. We're just going to create a standard Python 3 notebook. So what we'll do is we'll say I'm going to click on this, and then it creates this untitled, and then this is like the file extension for a notebook. See, like Python notebook. Interactive Python notebook is what that stands for. And I want to give this a name. So let's save as. Save notebook as. And let's call it first. Try that again. Save notebook as. First notebook. Okay, and then literally you can run any Python you want on here. Okay, well, like it's kind of like using the Python shell or Python script. The only difference is you're writing it in this interactive notebook. So the rules of Python still apply, but like let's say I want to install Numpy, right? Okay, I haven't installed Numpy yet, so I can actually add pip install Numpy in here. So that way, if like let's say I decide to send this notebook to somebody, and they open up, they have the notebook server running, but they don't necessarily have a particular library that I use. By doing my pip installs here, it'll make sure that it installs anything I need at the very beginning of them looking at the notebook. Okay, and actually it's Numpy. Okay, so if I hit enter here, okay, and then this is referred to as a cell. Okay, and I can keep adding more cells. So you can see right there, insert cell below. And right now it's not doing anything yet, but like let's say I print, well then I do like pip, import numpy. Okay, and then I'll add another cell, and then I'm going to print numpy. Okay, and so I'm writing these lines, but then when I hit this play button, it's just going to literally evaluate each line of code and then print like the result of that expression right below it. Okay. Name numpy is not defined. Well, it's been a while since I've used numpy, so let's go bring that up. The numpy documentation. Web. Here we go. Getting started. Yep, we put pip install numpy. So numpy is np, so let's do it that way. That's actually another browser tab. That's the part I never get used to. I always want to open up VS Code to go work on the code. So import numpy as np. np. And I think also what I did wrong before is that I think I still had this highlighted. And when I hit play, so it started highlighting for this. So I really want to kind of start here. So see there, now it's installing numpy. And the next time I run it, it's just going to say, hey, you've already satisfied this requirement. Then let's keep it running. Okay. And then let's run that one again and see like that's all working. Cool. And that's essentially what we can like do here. So, and then we can start applying. I'm not going to get too deep in the NumPy library, so I'm just going to show you just like normal Python stuff. So if I were to create like, you know, cheese equals one, well, let's create like multi-dimensional array, 1, 1, 1, 1, 1, 1. Okay. And then I say I want to print cheese. There's that cell, and again I can hit play, evaluate it, and see it prints that out. Okay, and then again that cheese variable continues to exist, so I can print cheese again. And I can hit play. Okay. So again, there's going to be different libraries that are going to allow you to do, again, NumPy, Pandas, are going to allow you to pull in data from different sources. So then what I may do, since I'm in this folder, okay, I may create like inside my notebooks folder, I may create like a sources folder, new folder sources. Okay, and then I might put in like CSV files, JSON files, whatnot that I need to load up there so I can then work with it. Okay. But let's kind of just take a quick look at the NumPy documentation so you can see what it is. But bottom line, basically what it does allows you to create NumPy arrays. These NumPy arrays are typed arrays, which means that if you do an array of like integers, it's an actually array of integers. You can simply add strings to it. And the beauty of that is that it can allocate the memory better because it doesn't have to allocate like, you know, it doesn't have to make sure it allocates enough memory for any possibility. It can just be like, okay, well, we're doing 8-bit integers. So all I need is a bunch of spaces for 8-bit integers, and if I need to add something, I'm just adding like that much space. It just allows it to operate a lot more, and allows it to kind of lock down like more sequential memory. So overall, it's going to run a lot faster than using a Python list. On top of it, it has all these sort of really interesting functions for really being able to generate arrays real quick, being able to like plus arrays real quick. like for example. Okay, let me just see here. Just generate a basic array right there. So you can see just to generate a NumPy array, it's pretty straightforward. You just kind of do np.array, because again, we imported it as np. So if I were to sit there and say, okay, npr1 equals np.array, and we'll say this one is 1, 2, 3, 4, 5. Okay, and then npr2 equals np.array 6, 7, 8, 9, 10. Cool. And now if I wanted to create like another array that's a combination of these two arrays, it's just simple as doing this. npr1 plus npr2, and it will concatenate those arrays. So print npr3. And yeah, so let's evaluate that. Oh, no, that doesn't concatenate. That actually literally adds them. Okay, yeah, because you can do operations like that. And again, that's what makes NumPy so cool. Okay, the way it handles all these operators. So literally what it just did is that it said 1 plus 6, 2 plus 7, 3 plus 8, 4 plus 9, 5 plus 10, 15. So you can literally like do mathematical operations. So I can also just do like, let's say if I were and the cool thing about like the notebook is I can just change this to minus, reevaluate it, and then I get that minus 5. Yeah, actually all of those are going to result in minus 5. So that makes sense. That's neat. Okay, so you can do cool stuff like that. Now, as far as concatenating the array, I remember there's a pretty interesting way of doing that as well. And again, you can do things like you can generate arrays of zeros. So like, for example, if I do np.zeros, like you just need an array. Like you just know you need 8 spots because you need an array so you can loop over it, generate the data from there. I can just create generated data, an array that just has, it's already automatically filled with particular data. So you can see here np.zeros. I pass it a number, it'll generate an array with that many zeros or that many ones. So there's all these fun functions. So here's like a range. So a range will generate an array that is in a range between 0 and 3. Okay. So pretty straightforward. Let's just see if there's any other really cool low-hanging fruit to mention. Here we go. There's a concatenation. np.concatenate. That's originally what I was trying to do. Okay, so then technically I would be np.concatenate. And then what we would do is we would just say npr1, npr2. Okay, let me just make sure I got the syntax right. Concatenate AB. Oh, you got to put them in a tuple. Okay, so again, a tuple is just basically Control Z. So you pass it a tuple of arrays, okay, and then that it will concatenate them. So let me see if I hit play there, and there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, it gives you a lot of powerful methods for working with arrays, but more importantly, it makes these arrays much faster. Like that's really like the big deal. A lot of these things wouldn't necessarily be too hard to do with a normal Python list per se using normal list methods, but this is just going to be a lot faster. And especially when you start getting to much more complex arrays like matrices and 2D arrays and stuff like that, you can start doing a lot more cooler stuff. Okay, so I'm not going to get into every operation here, but that's the purpose of NumPy. So you can kind of play around with the different functions. And then what you do is, as you need to assess data sets, you can use it there. And again, Pandas is going to be using these NumPy arrays under the hood, okay, along with like the Python, with the Apache Arrow format, which is a more recent sort of thing. Cool. So I'm going to leave it at that now. In the next video, we'll probably kind of explore Pandas and actually loading a data set in there and like playing with it. But hopefully now you got your space set up, so now you know, like, hey, anytime you want to go work in your notebooks, you would just turn it on, just turn on the server in your notebooks folder after activating your data.py virtual environment, and you're good to go. So right now I want to shut down that server, so I'll do Control C. It says, yep, shut down the server. And again, if I ever want to turn it back on, I would just type in Jupyter Lab again in this folder, so that way it's being served out of this folder. Although if I wanted to just serve like that one notebook, okay, I could do voila first notebook. So if I use voila, it'll serve just that one notebook. Okay, and so there it's just serving that notebook as sort of like a website. Okay, I don't think I can edit it from here. So like the idea here is like voila allows you to serve it So when you're done with the notebook, someone else can kind of like see it, and you can create interactive notebooks. Like there's like little widgets you can add, so that way people can like change numbers, and then it'll like, so that changes the data, which then changes any kind of visualizations you add, etc. But so that's what Voila is for. Cool. So I'm going to close that out, shut this down, and yeah. So that's video 1. I'll see you guys in the next one. Have a great one and enjoy.